but it was the recognition that clean tech startups are typically not a great fit for traditional VCs. And then the reason is that the timelines to really building a very valuable and large business are extremely long and often longer than the typical lifespan a fund, which is 10 years. And there's some fundamental mismatch in business models, both in how long it takes for a clean tech company to get to market and to build value, and also, I would say, the types of exits that really make sense for clean tech companies.
Hundreds of thousands of researchers around the world are working to improve life and address imminent threats to humanity. Often their research ends up in the scientific valley of death in the form of publications and patents that never see the light of day. That is about to change. Welcome to the Lab to Startup podcast, hosted by Naresh Sunkara, founder and executive director of the Berkeley Postdoc Entrepreneurship Program at the University of California, Berkeley. This show has two main goals: share the stories of those who have successfully founded startups based on their own research, and highlight resources needed to help those aspiring to launch startups in the deep tech space. Whether it's electric cars, vaccines, addressing climate change concerns, or possibly establishing life on other planets, Naresh and his esteemed guests want to help scientists, engineers, faculty, and researchers bring their innovations to market. Learn more and subscribe today at labtostartup.com. And now, here's Naresh.
My guest today is Richard Wang, the founder and CEO of Cuberg, a startup building the world's first aviation-certified lithium metal battery pack. Robert is also the CEO at Northvolt America, which acquired Cuberg in 2021. In this episode of Lab to Startup, we talk about the current challenges around battery innovation and solutions that are being worked on, followed by Richard's journey from being a Ph.D. student at Stanford University, where he also picked up his startup education, the technology behind lithium metal battery that developed, lessons learned from customer discovery exercises, and also the validation of battery performance claims by the Department of Energy. And then we talk about the reasons for going after the aerospace industry, stories about his fundraising journey, and finally about being acquired by Northvolt. Richard is one of the best storytellers I know of and an earnest scientist and entrepreneur. You'll know why I call him Ernest as you listen to my conversation. I really had fun having this conversation, and I hope you enjoy it as well. All right, Richard, welcome to the show. If you're comfortable, maybe you can start by providing a summary of the major challenges in the battery industry and a high-level overview of the technologies that are being developed to address these challenges. You can consider this as the state of the union for battery technologies, because this will help set the stage for a conversation around your startup, Cuberg.
Sure, absolutely. And it's a pleasure to be here, Naresh. So taking a step back on this question, the battery industry has many, many different facets to it. For the purposes of this topic, I won't touch so much on the challenges of the battery industry as a whole, but focus more on the technology innovation aspect of it, which is likely what most founders are more focused on these days. And so when you look at essentially starting and operating a successful battery startup, the key challenges that I see really are related to manufacturing scalability and both the engineering complexity that underpins that, as well as the cost and capital needed to get to manufacturing, as well as the timelines to get to market. And all of this against the backdrop of extremely high level of competition from the lithium ion industry that has deployed tens of billions of dollars in capital already, has highly, highly refined and optimized manufacturing processes, and a very, very low manufacturing cost point that you have to compete against. So I think the whole manufacturing scale journey is likely the single biggest challenge for any new technology, and one that I think is regularly and easy to underestimate the difficulty of. There are also, I think, a couple other main factors related to challenges in innovation. One is, I would say, the mismatch or disconnect between academic work and industrial work. And a lot of this focused both on R&D that either answers technical questions that are incorrectly scoped or not so meaningful commercially, or innovations that are effective, but ultimately have challenges in terms of how they scale up. And then finally, the third big challenge, I would say, is how do you go to market with a new battery technology from a commercial perspective. And what I mean by this is, how do you fundraise for your company, and what investors do you take money from, and what markets do you pursue? Because the reality in the industry, looking at the history of battery companies, is that the automotive industry, I see almost got like a siren from mythological times, where the allure of the automotive industry is immense because of the scale of that market, and that's what VCs want to pursue and where you get your money from. But at the end of the day, it's an incredibly difficult industry to penetrate, and really not an early adopter of new technologies when you look at the dynamics of that industry. And so how do you really define a go-to-market strategy that works effectively, rather than just assuming you're going to make it big in the automotive world? So those are my summary of maybe 3 key challenge areas. For summarizing on technology, I will just very quickly give an overview here. I would say beyond the lithium ion world, which is focused on typically nickel-rich NMC cathodes and graphite anodes at present day, of course, you have on one big stream anode innovations, and these are things like silicon anodes that are increasingly starting to get deployed in early commercial applications like SELA nanotechnology in smartwatches, and a few other areas where silicon is starting to get introduced to increase energy density and fast charge times. A little bit longer term, you have lithium metal anodes, which is also what Cuberg is working on. That's the holy grail for anode technologies, and ultimately how you get to maximize energy density in a battery, as well as output power and other key performance metrics. And then I think on the other big areas of innovation would be on the cathode and the electrolyte, the other 2 main components of a battery. On the cathode side, you have an ongoing debate between lower cost chemistries like iron-based and manganese-based chemistries versus the high energy nickel-based chemistries like NMC. And then you have a little bit further afield sulfur cathodes, which are much, much lighter weight and lower cost in materials, but with significant scientific and commercial challenges. And then the electrolyte that binds it all together, typically you have liquid electrolytes these days based on carbonate organic solvents. The biggest thrust in this area is to move towards semi-solid and fully solid state electrolytes, which provide improved stability and safety, hypothetically, and allow you to integrate more energy dense materials, but also is incredibly difficult to scale up from a manufacturing perspective. So high level, this is where materials innovations are taking place within the battery sector. Of course, many, many other areas on top of this, as well as supporting functions like manufacturing, quality, and so forth. But high level, I think that captures it.
So maybe we can talk about the specific problem that caught your attention before you launched Cuberg, solutions that existed at that point, and what convinced you that there is a need for a new startup.
So I started Cuberg back in 2015 when I was still finishing up my Ph.D. program at Stanford. And at the time, I was actually fairly skeptical of battery startups, because back then we were sort of in the midst of the aftermath of the clean tech bubble. And a lot of battery startups around that 2015 timeframe had either already gone out of business, like A123 had gone bankrupt and then their assets had been acquired. Other examples like Envia, which sort of ultimately went up in flames because of a scandal around data misrepresentation and so forth, or Sakti 3, which was acquired by the Dyson Group, but ultimately, again, with claims that did not stand up to reality. It was a dark period for battery innovation. The fundamental question I really looked at was, why were so many of these startups failing to actually deploy relevant and useful technologies to the marketplace? It seemed like something was broken in the funnel of technology coming from the academic world and going into commercial operations. That, more than anything, I think inspired my thinking around Cuberg and what kind of a company I wanted to build and how to manage this company's strategy to actually successfully make it to market. From a product perspective, it was clear to me that you needed to continue pushing the envelope on energy density and performance. Historically, that has always been the key defining metric for more advanced battery technologies, because energy density is ultimately what drives both what kinds of products you can power with batteries, as well as the cost of integrating them into a system. And looking at the landscape, lithium metal was pretty clearly the end goal for anode technologies, and really the area where it had a confluence of a few factors. It was this one-shot improvement that would really create a step change improvement, something where if you knew you succeeded, you would make a massive impact on the industry. It would not be a marginal improvement. And also an area where I could see a potential pathway to enable a lithium metal chemistry without drastically changing how battery technologies get scaled up and manufactured. That was the key confluence for me, is figuring out a technology where you truly will make an impact if you succeed, but also where you can do it with relatively minor disturbance to scale up approaches. That's how we got started. And then eventually ended up on our pathway, which is focused on a liquid electrolyte innovation. It has a lot of the stability benefits of solid state, but fundamentally is a liquid electrolyte compatible with existing manufacturing processes, along with a lithium metal anode that is relatively easy to integrate into existing cell design and tool sets.
Maybe you can talk about your educational background more, because I know you got your PhD from Stanford. Shed some light on the training and the ecosystem and access to people in terms of brainstorming, like before you started the company. Like, did you consider getting a job, or why a startup route? How did that evolve, if you can go through that process?
I started my PhD in 2011 in the material science department at Stanford under Professor Itsui, very well-known academic in the battery world. I was actually originally studying this class of batteries called Prussian blue batteries. And it's a class of materials that is known to have very, very high rates of ion intercalation and deintercalation, which allows you to use it as an electrode material for batteries that need extremely long cycle life. It doesn't have much energy density, though, so typically used for grid scale, utility type, low cost battery applications. And that was the focus of most of my PhD. It was fairly technically specific, as far as many PhDs often are, focused on the crystallography of these materials, and did a lot of work at SLAC, at synchrotrons, and so forth, studying crystallography, understanding the mechanics of ion insertion of a variety of ions into these battery materials. I would say the technical training in my PhD, a lot of the specifics ultimately didn't end up transferring to what we do at Cuberg, but I would say that a few areas that were important in that educational journey. One were the basics of really becoming technically an expert at electrochemistry, at battery science, and so forth, which just underpins ultimately developing a hard new technology like a new battery material and battery cell design. Also, a lot of learning around entrepreneurship. And so Stanford does have quite a lot of resources for students interested in entrepreneurship. And so I made use of a few of these programs. Originally, one of these early on, I recall, was this weekly or biweekly lecture series, I believe was operated by the business school, and they would invite a lot of entrepreneurs from Silicon Valley to come and speak at this program. And it was, overall, I would say inspirational more than anything else, but, at that early stage, helpful for understanding what it means to go and build a startup and to think about creating your own company and the pros and cons and strategy and so forth. One particular experience I had that still is very memorable was actually I participated in this class that was provided by Peter Thiel, the co-founder of PayPal, a famous entrepreneur. And he actually gave a lecture series at Stanford, I think back in maybe 2013 or 2014, around it. And that lecture series ultimately became also his book called 0 to 1, just focused on disruptive innovations and what really separates technology startups sort of on a first principles basis from any other small business that you might be creating. And a lot of those original principles I learned from that class did apply to how I thought about operating Cuberg, and gave me a good deal of inspiration to think deeply about the problem of entrepreneurship in this industry. Then finally, I would say my sort of most significant formative experience for being an entrepreneur was another program at Stanford called Stanford Ignite. This was a program offered by the business school, and it was a 4-week, basically full-time crash course in the summer into essentially what is done in an MBA in terms of like a crash course business school education, and focused specifically on technology-driven entrepreneurship. So a lot of things overall that are sort of general about business management, as well as specifics about a startup, such as how do you think about venture capitalists and investors, and how do you think about their business models and what is success for a VC, and how do you align your interests with who you work with and who you fundraise from, and so forth. And so that program ultimately gave me, I think, much more of a context and a framework to think about how to go about becoming a founder and an entrepreneur, and ultimately really gave me the confidence to go and start Cuberg as well.
That is great. I think taking those courses, being intentional about exploring the startup is a great thing, is the foundation you need. What were the initial conversations like? Like when you thought about launching Cuberg, who did you talk to? Like, what are those formative experiences like as you tried to make this decision?
After going through these classes, I think there were a couple key, let's say, early supporters and mentors that really helped to inform my decision to go and pursue this full time. And so one particular individual is Brian Bartholomew's, and he is still at Stanford. He runs the Tomcat Center for Innovation, which is a program, I believe, funded by Tom Steyer and his wife, and focused on really providing very, very early sort of pre-seed funding for students with interesting clean tech ideas to try and look at what it would take to commercialize. And so Brian himself, more than given the funding, Brian himself was an excellent advisor and really gave a lot of encouragement early on that really reduced the sort of barriers to entry to becoming an entrepreneur. And I think what I started to realize was that it could seem like this massive thing to become an entrepreneur and to start a company. And it is, of course, in many ways. But even with something as big as this, you can really take it in a step-by-step fashion and grow it organically one day at a time. And he connected me with key individuals that helped advise the company's early days, as well as potential investors and customers and so forth. That's actually also where I met my first investor, was through the Tomcat Center. And so overall, a very encouraging person that really gave me some of that early personal confidence to go out and do things on my own. I think the other most significant factor after we started the company was our relationship with Cyclotron Road at Lawrence Berkeley Lab, now known as the Activate program. I got introduced to that through the Tomcat Center as well. And ultimately, that program, where we spent the first couple years of our company life, 2016 through 2018, was hugely instrumental for really forming the DNA of the company and giving us the early support we needed to then grow it.
This is so important. I think those early believers and advisors play such a phenomenal role in shaping a founder's view, and those connections they bring to the table. I hope everybody gets those things. And Stanford is a great place, of course.
I was going to add as well, it's certainly, the resources they bring and the networks they bring, but also I think for founders, a big portion of it is sort of going through the personal development and sort of emotional journey to change your mindset into somebody who's starting their own company. And having that sort of support system to guide you through difficult times and to support you on your journey and be a cheerleader is also, I think, intrinsically important in addition to the concrete resources they provide.
Absolutely. And we will come back to Activate and those details in a bit, but I just want to dive into your groundbreaking lithium metal battery technology and how it is enabling improvements in energy density and power output, if you can go deeper into that subject.
So high level, compared to a lithium ion chemistry, we have changed our graphite anode to an ultra lightweight lithium metal anode. So lithium metal, of course, is the reduced form of lithium. And as we charge and discharge our battery, literally you have electric deposition taking place when you charge the battery and lithium growing, and then electrostripping of that same material when you discharge your battery. And then lithium metal, the challenge, of course, is that while it has fantastic energy density and also allows you to have fantastic discharge power for a high energy and high power battery, the challenge is lithium metal is one, highly reactive and flammable as an element, and typically is very difficult from an electrodeposition perspective in liquid electrolyte system. And this is because lithium has a propensity to form dendrites and to grow in ways that are very mossy and high surface area. And ultimately, these dendrites can penetrate your separator and cause your cell to fail by short circuit. And lithium, one of the reasons lithium is so prone to this is because lithium, at the end of the day, is extremely reactive material. It has a very low reduction potential, so it will electrochemically reduce just about any material that it comes in contact with, virtually any material. And ultimately, that means that you need to design a new electrolyte system that interfaces with your lithium effectively, that really helps to stabilize that interface with the electrolyte so it is not continuously decomposing your chemical system and forming dendrites and degrading. So that's the core of our technology design. Is a new liquid electrolyte, non-flammable electrolyte as well, that enables the integration of lithium metal with good level of reliability while also being highly compatible with lithium ion manufacturing processes. And from a product perspective, what this means is a battery cell that can deliver energy density per weight about 50 to 70% higher compared to the existing lithium ion systems. And when you look particularly within the battery world, the niche where we see early deployment for our product is in areas that need both high energy and very, very high discharge power at the end of the day. So the most demanding kinds of battery applications. And compared to the high power lithium ion cell, which might be on the order of 240 watt hours per kilogram these days for a high power cell, our lithium metal cell hits over 400 watt hours per kilogram. So truly a very, very large leap in an industry that typically improves at a few percent per year in terms of energy density. We have now developed this into a pouch cell product. So this is the cell format that goes into consumer electronics, as well as a wide variety of EVs like Chevy Bolts, and many of the EVs on the market these days do use pouch cells for automotive applications. And we have a pouch cell now that's been optimized for electric aviation applications, which is our prime customer these days.
Those numbers are fascinating and reminds me of something you mentioned earlier about how some of the companies went up in flames because they couldn't prove the numbers they put forward. And I read somewhere on the web that the Department of Energy validated your battery technology. Is it a regulator of sorts? Or I mean, it'll help to understand the validation process, if there is any, and the timelines?
Fantastic question. And I think an area of historical, let's say, pain for the industry, because I think what you see in batteries goes back to Thomas Edison. Actually, Thomas Edison himself was a big skeptic of battery technologies at one point because he himself, as a businessman, I think had been burned by unscrupulous battery entrepreneurs over promising. So this is nothing new in this industry, unfortunately. And it really is, I think, a confluence of a couple factors as to why this industry is prone to over promising. I think one is that batteries are, let's say, phenomenally complex, both technologically in terms of how many different factors that are confounding have to come together to make a good battery, as well as the complexity of understanding a battery from a product perspective. And so when you look at product requirements for a battery, there are literally dozens of critical metrics that all need to be met simultaneously to ensure you have a compelling and useful commercial product. And it's really easy to focus on one or two top level metrics. And, by necessity, you need to, because you can't always list 30 metrics every time you talk about your technology. So you list like the top two, which might be, energy density and maybe cycle life or something. But the reality is there's so many more things that you need to do to make a commercial product out of a new battery technology. And I think that has led entrepreneurs to either intentionally or unintentionally be blind to some of the downsides of the technologies they've developed and overestimate the maturity and readiness for technologies to commercialize. And that's what's led to this whole sort of discrepancy between what entrepreneurs say and when technologies and products actually make it to market. In this area, one big challenge of the industry historically has been a lack of transparency and independent validation and verification of products. And that process, ultimately, it's not 100%, but it does give you significant assurance in terms of a baseline of where does this product or technology sit on the maturation life cycle. And so when you think about needing to independently verify your technology, and you think about what's actually needed to get to that point, you need to first make a prototype of a certain reasonable commercial size. That alone is already a big leap because many companies talk about performance claims at a very, very small subscale lab prototype scale. So first, you need to scale all the way to where you have a real commercial prototype that already basically cuts through a lot of the ambiguity around assessing a technology because you need to figure out manufacturability, you need to figure out a basic level of process control, you need to be able to build it at a certain scale with a certain reproducibility, and then you have to ship it to a company that might be testing it in a very different condition, different engineers, different test equipment, environmental controls. It has to be shipped, through FedEx, and they're going to, drop it in a box and bump it around in a truck. So all these things complicate a technology's viability. And so if your product can then be shipped and sent to this independent entity and still operate as you promise, then you've really passed a whole number of hurdles in terms of validating your technology. And then, of course, it's actually, does the product do what you say it does? And in this case as well, being able to validate independently is a big proof point for battery entrepreneurs. So we went to the DOE back in, I think it was 2020, I believe, was when we did our independent validation and basically sent 20 or 30 samples to them and had them cycle it for us in a number of different conditions. And then we're able to get the data so that we could publish, which is hugely valuable for validating our company and also was, I think, a significant factor in our acquisition later by Northvolt. We've done an updated round of validation just last summer with a new generation of our product, and we'll continue doing this in the coming years because I think it's critical to really demonstrate what you've actually achieved in a very open way to the community.
This is very critical, as you mentioned, and it makes me think because a lot of founders build technologies without thinking through what could go wrong or what claims you can make or cannot make. I wish founders use a little more caution and be a bit more prepared. And I'm assuming you had a fantastic team helping you think through and work through all those things. Maybe you can talk about that co-founders you had on your team and how you grew that team. So you have these checkpoints of not fooling yourself and building the right product so that it'll stand the test done by the DOE.
And just, one final point on the validation is that journey also certainly was not a trivial one for us. We always had the view that you need to get out of the lab and you need to send your products out and really get that sort of outside validation, whether it's a customer or it's a test lab, that what you're doing has real value. And we also learned a huge number of lessons in doing that, things that were totally unexpected. And I think that is part of the value of the exercise, is if you force yourself out of your comfort zone and to do something new, it really makes you learn these lessons much earlier on in a development cycle rather than just doing experiments in the lab for many years before you feel that you're ready to take that leap. So definitely something I would encourage entrepreneurs to do earlier in their life cycles, to make larger prototypes, ship them out to customers or to test labs, and ensure that you're learning these critical lessons.
Maybe I can interject at that point. Like you said, you sent these samples out in 2020 and like you acquired in 2021. So I'm assuming the process was pretty fast. Like in a year, you're given an approval or given the numbers by them.
Not quite. So the actual test process was reasonably fast, maybe 3 to 5 months or so. But getting to the point where we could actually ship something to the DOE and get the results we wanted, that was a long time. That was probably a couple of years. We first started shipping early samples to customers probably in late 2018 and, ran into all kinds of complicated issues that we did not expect, quality issues and, all kinds of things where our cells were not behaving as we had advertised or as we had tested internally. And we needed a couple of years to really dial in what we were doing and understanding those basic failure modes to the point where we could ship something reliably. So it definitely took some time to get there. But yes, once you have the product, the test itself doesn't actually take that long.
Maybe you can highlight a couple of complexities that you run into after submitting the samples that you had to go back and correct. Any understand?
Sure. So in earlier instances of this, shipping to very early customers, sort of like alpha customers and so forth, early stage, a few things we saw were that quality control is something that early technology startups don't really think about. And you end up having really way too many uncontrolled variables when you're trying to produce a new prototype. And it's something where internally you can kind of figure it out because you can just make another sample and then, okay, now this time it worked. But when you're shipping something out to a customer or to a test lab, it has to work. You really need to develop a different level of control around all of your production variables, at least a basic level of control to get to that next prototype stage. I remember one crazy instance where we shipped, in this case, it was an investor, where we shipped some sample cells to an investor and they came back to us and said that the capacity of the cell was off. And we're like, okay, why is the capacity off? We looked at it and it turned out that even the weight of the cell was off. And it turns out that, in the manufacturing process, we just had miscounted the number of layers in the cell. And something as fundamental as that, but like if you don't weigh your cell, you have no easy way of actually automatically catching that something has gone wrong. And then you end up, just looking unprofessional because you shipped the wrong number of layers to a cell, to an investor that you thought. So it's a pretty basic things like this. And obviously we're still in that process of continually refining our quality control parameters. Now it's a whole different level, but still it's this area where you have to continually refine how you manufacture that and control your variables.
I'm building my second startup now. And I think from my lessons from the first lesson of startup was the QC. And it's so important to have those placeholders to check yourself. And I hope founders are more thoughtful about this.
Lesson learned.
Maybe that's a nice segue to go.
Yes, absolutely. So back on the team question, I started the company back in 2015 with one co-founder, Mauro Pasta, who was a postdoc at the time that I worked with for several years at Stanford. He was with the company for about the first year of its journey. He actually eventually left Cuberg and became a professor full-time at Oxford. And so he's still a professor there at Oxford today. And then I became a sole founder running the company. Definitely not easy. I would highly encourage founders to find co-founders. I think there's actually a book has been written about this, that like the optimal number of founders is 3. I think if you look at the historical sort of success rates of companies, then it's followed by 2 founders, 4 founders, and then 1 founder. So being a sole founder is definitely not easy. Can be done, but it's not easy because you have to do everything. You have to do technology development, you have to run the business, you have to do all aspects of it. And that's what I ended up having to do after my co-founder unfortunately left. Required me to ultimately hire a team early on rather than rely on my co-founder to help manage, and to really hire people that were fairly autonomous and could operate in that very, very early kind of undefined and uncertain early startup environment. Especially as a first-time entrepreneur, I would say hiring was one of the most challenging things that I went through, and where I ended up learning a ton of lessons about what it means to build a company and a team and a culture and so forth. And one of the most absolutely critical, I think, skills that entrepreneurs need to focus on. I think that's really underemphasized, sort of typical business training and so forth. So one aspect of this is that as a first-time entrepreneur starting this really speculative early-stage startup, it's very hard actually to attract people to your company because it's a huge amount of risk and they don't know if it's going to work out, and they have many other opportunities in the industry. And you end up having to look pretty hard to find people and end up typically finding people that are really early in their careers and don't have a lot of experience themselves. And so you end up collectively trying to figure things out without really any experience on the team. And it's one of the sort of challenges of being especially a first-time entrepreneur is how do you attract talented and experienced people to your team. We did have some fantastic people in the end that we found who really were critical to the early days in the company. And they were individuals that ended up having the right kind of mindset for that sort of undefined early startup environment. And we're happy to go and just wear many, many hats, do whatever it needed to be done, and to try and solve problems kind of out of the box and creatively. Definitely, I think in retrospect, I've learned a ton about how to hire and the importance of getting critical people to help support your entrepreneurial journey. I think a big aspect of this also that was learning was the importance of company culture. This is something that we did not end up really developing until maybe 2 or 3 years into the process. It always felt to me like one of these, let's say, fuzzy or ambiguous or hard to define things that it wasn't really, I didn't really know how to interview for or how to establish company culture, and ended up learning it's something that you really have to do quite thoughtfully and proactively, and really go out and tell people what is your company culture explicitly, and really try to interview people to see if they fit in that startup culture that you have created. Had some lessons learned with some hires that didn't go as well as I had hoped. Typically ends up not being so much, let's say, technical qualifications as it is how do people get along with each other? Do they fit in with a team? Are they having conflicts or disagreements? Can they work together in an efficient manner? And if you don't have the right company culture, even if you only have 5 people, you can have an endless array of interpersonal issues if people don't click. It really taught me the importance as well of being very conscious and proactive about establishing company culture as you build that early team.
Hiring is hard. If you don't mind, I want to go down this thread a bit more. Let's start with the finding the people with the right mindset you mentioned, where they would put on multiple hats. What did those people look like in hindsight?
In some sense, it's a self-selecting bunch of people because anyone who isn't at least partially in that mindset isn't going to be crazy enough to apply to your very, very early stage startup. But still, there are, let's say, some common patterns here. So I would say one aspect are people who either don't have the experience to know that something is wrong to do, or let's say are happy to challenge preconceived notions. And so the sort of type of personality who's not a good startup fit is, I think, somebody who comes in and says, okay, I've seen this before. This is how we do things, and this cannot be done because I've been at this big company where we failed to do this. And at a startup, you have to realize that sometimes not knowing your own limits is very helpful. Or maybe you know the limits, but you do it anyway because, as a startup, you have a totally different set of trade-offs on risk and reward and what you can and cannot do. So it's people who are, I think, brave enough to sort of throw themselves into a problem without risk of failure, and who are not scared to challenge sort of preconceived notions on how things are done. And we ended up mostly hiring very early career people. And I think this is a good and a bad. The good part is that these people don't come in with preconceived notions, and you can really reinvent things in a way that is very fundamentally innovative and out of the box. But at the same time, as your company matures and grows, that experience starts to become more and more useful as you need to build up structures and you need to build up capabilities that do come with experience. So, but typically, especially as a first-time entrepreneur, a lot of early career individuals who are just very talented and intelligent and want to do something different and try something out, often their first career out of academia. I don't know if, reflecting back, that I don't think that would be the only profile I would hire for, but that's mostly what Cuberg started out with, kind of out of necessity.
What was the craziest hire in a good way, like of the people you hired? Like, what were the thoughts like, and what impressed you, and what do you like in working with this person, if you had to pick one?
So I think the most out there one early on, which worked out really well, still good friends with the company, was a scientist that we hired who actually started out as an intern at the company. He had a very atypical profile. So he was actually a theoretical physicist at UC Berkeley, doing his Ph.D. there, completely unrelated to anything in the battery world. But he decided that physics was not for him as he was wrapping up his Ph.D. and he wanted to do batteries instead. And we didn't really know, what to think about this because he had no qualifications in terms of actual skills for getting into the battery industry. But it seemed like somebody who was, one, a very good, let's say, cultural fit with a very early stage startup, and two, somebody who could learn and grow very, very quickly. So we kind of took a gamble, right? This was at a time in the company where there were only like 5 full-time employees. And so deciding to add one new person was a huge decision for us. That was one slot that we couldn't use to go and find somebody who did have experience. But we decided to try him out as an intern, ended up, working pretty well, and we had him join the company full time. And he ended up developing a lot of the core technologies that we still use today. And so it ended up working really well, even though it was a very unconventional background. And I think especially as a early stage, let's say, especially as a first-time entrepreneur, where you're not able to hire talent from more traditional sources, you have to think outside the box and try to look at who fundamentally fits, even if they don't have the right technical background. And I think that's something I learned as well, is that it's much more important to hire for cultural fit and sort of fit for a startup mindset rather than hiring for technical skills, at least early on in the journey.
Let's go back to something you mentioned earlier about how you improved on the hiring process over a period of time. Like, what did that evolution look like? If you had to pick one question you asked every candidate, if it's a make or break for you, what would that be?
Our hiring process has evolved a good amount, both in the process and the questions that I focus on and so forth. On the process itself, I actually remember reading this, I think that was a blog post from this company called, maybe it's Carbon Lighthouse. I think they're based in the Bay Area. Yeah, Carbon Lighthouse. I don't even know how I came across this guide, but at the time they had published this, blog on hiring. Nothing specific to the clean tech industry per se, but basically a pretty thoughtful analysis of, given studies that people have done in industry, what kinds of traits are important to screen for and so forth. And that's really where I started to develop an inclination for focusing on cultural fit questions and more sort of emotional intelligence type of questions rather than just hard technical questions. I would say, one question that I ask that I find reveals a lot about a person is to have them reflect on their work environment, where they're working currently, where they've worked previously, and to describe what it is like to work there as an employee, how people get along, what works well and what doesn't work. And, depending on what they say and how they say it, it reveals a huge amount about a person, both in terms of the depth of their understanding of workplace dynamics and interpersonal dynamics, which gives you a sense of their emotional intelligence. And it also gives you a sense of how they talk about their coworkers. Do they constantly complain? Do they have a lot of negativity? Do they appreciate where they work for? What do they see as things that are important or not important in a workplace? And that really helps you to establish some sense of cultural fit. That's, other than, of course, standard technical questions, that's my sort of top question that I find is very helpful for revealing what a person is like.
For those who complain about the previous workplace, I think those are the people who are trying to move to a different job. How do you filter noise from the signal?
Interviewing is very tough because you have to normalize by a lot of soft factors. It is the case that some people just either from a communications perspective, don't interview as well or as smoothly. Or some people, they don't have that many filters. They talk about the negative and, it is what it is, even if they're not themselves, let's say, a bad person. And so I think it's one thing to just explain why you've left a workplace because it doesn't work well. But I think how you talk about that experience is quite important. Is that person also self-reflective on how they got engaged in that environment, how they joined in the first place? Did they contribute at all did they try to fix the workplace in any way? And, was it more of a productive way that they engaged in that work environment, even if the workplace wasn't good? Or was it just they fell into this environment and they ended up complaining about it and then they left? So even if somebody's thrown in a poor environment, there are different ways to approach it. And so I think that's what you end up trying to look for.
I'd like to slightly shift gears and go back to something we mentioned earlier about Cyclotron Road. Can you talk about all the incubators and accelerators you considered before getting into Cyclotron Road, and why did you end up at Cyclotron?
Before Cyclotron Road, we looked at a few other options. Early on, we looked at Y Combinator briefly. We also looked at StartX, the Stanford organization. A lot of startups go through. I think we ended up formally applying to StartX. We did not apply to Y Combinator. But overall, the challenge, at least back then, that I saw with both organizations is that back then, they didn't really have any practice focused on hardware, hard tech, and clean energy, and so forth. I think that's changed quite a bit. I think Y Combinator now has quite a few more companies in their track record that do focus on hard tech and on chemistry innovations and so forth. But back then, that was not really the case. And what I found was the mismatch was one in terms of timelines. Typically, those accelerators are very short, too short to really do something significant in hard tech in terms of making prototypes and de-risking your company in fundamental ways. And the support they give you is not necessarily the support you need exactly, both in terms of one, you need basically hard support, which is facilities and lab space and all these kinds of things that you just cannot pay for as an early stage company, and they don't really offer you. Another aspect is how you think about the typical business wisdom, especially sort of historically, that was founded in the Bay, was focused on software startups and so forth. And that kind of advice really is not that relevant in a lot of ways for hard tech. I mean, there are some lessons, obviously, that are shared, but you have to significantly adapt that framework and that advice for a hard tech company. So the unique thing about Cyclotron Road is that it was designed to meet exactly this purpose. Instead of 3-month or 6-month program, it was a 2-year program, which gives you enough time to de-risk your company, focuses specifically on clean tech and the unique challenges that it has in scaling, and builds a network of mentors and investors that was focused on clean tech. It gave you the lab space and the resources technically at Lawrence Berkeley Lab to do what you need to do for a couple of years. And so in many ways, it was a very different program from anything else out there. It also gave you roughly $500,000 in grant funding, which is substantial for early stage startups, so that you can actually hire a decent team, not just one software engineer to make your MVP, but actually a decent team to go and figure out what your product is, and let you get to the point where then you do have some options in terms of who you fundraise from and how you grow your company. So absolutely, I think, instrumental and critical program for us. And definitely, I think the one aspect in our company journey that I would say was most impactful.
You mentioned about YC and startups. Has anything changed in terms of, I don't believe it changed. I think the programs are too short still, and I don't think they still have any incubators where they have facilities and infrastructure. Am I right?
I haven't caught up with those organizations recently, last couple of years, so I can't say for sure, but definitely the model still isn't exactly suited. I mean, maybe they fix things here and there, and they do have more companies going through in that vein. But still, some of the fundamentals of how those programs are designed isn't that well suited for clean tech companies. I mean, you see some companies go through and they have some value they get out of it, but it's not sufficient at the end of the day.
I had Matt Price on the show. He talked extensively about Activate, and facilities like Cyclotron Road, now Activate, are super, super important for deep tech. They just can't be treated like a software company. The speed doesn't work that way.
Exactly.
Biotech or energy, and the funding that they give you for about 2 years, I think that's invaluable. And maybe that's a good segue to talk about your funding journey. Looks like you got a bunch of grants to support your journey. Like, if you can walk us through the kinds of grants you applied for, how selective were you when we applying for those things, will help.
And I think helpful at this point to talk a little bit about our broader financial and investor strategy, because this was something that I developed both at Stanford Ignite and then at Cyclotron Road. But it was the recognition that clean tech startups are typically not a great fit for traditional VCs. And then the reason is that the timelines to really building a very valuable and large business are extremely long, and often longer than the typical lifespan a fund, which is 10 years. And there's some fundamental mismatch in business models, both in how long it takes for a clean tech company to get to market and to build value, and also, I would say, the types of exits that really make sense for clean tech companies. So I think we'll get to this later about our thoughts on our exit strategy. But my view, even very early on, back in 2015, was that traditional VCs were not the right source of funding for us, because my perspective was that ultimately the right approach for a company like ours was to go through a strategic acquisition with a large battery manufacturer that has the resources and expertise to help us actually get to market. And if you want to engineer for a strategic acquisition, VCs are not really the right profile, because they really want to push for an IPO and a sort of billion-dollar outcome. That's what makes their businesses work. That ended up forcing us to look at very, let's say, untraditional routes towards financing. And for us, this was two main things. It was strategic investors made sense, and typically sort of from the customer side, customer strategic investors that had similar interest to us in seeing our technology get deployed at scale. And then it was really a lot of grant funding, to your question, to help also keep our capital structure relatively lightweight so we could engineer a positive outcome with a strategic acquisition. Looking at specific grant opportunities, a few stand out to mind. Of course, there is the SBIR program, which I think is infinitely valuable for many companies. It's such a bizarre world, I would say, the SBIR world. In many ways, that's quite a learning journey in itself. at the conclusion of it, at least for battery companies, what I found was that the DOE was probably the best source, being most aligned with battery innovations. And we got a decent amount of the money from their SBIR program, which was quite instrumental. We got some money from the NSF, although for various reasons, I did not have as good of an experience with NSF, but that's more, I think, case by case. I think other companies have had also very good experience with NSF's SBIR. And then we tried to dabble in a bunch of DoD SBIRs. It was a very painful world, hard to enter, very sort of complex decision making and so forth. The one program within DoD that did work out for us was the AFWERX program through the Air Force, where they were much more, let's say, open-minded to new innovations compared to some of the traditional DoD ones that were very requirements-driven. And AFWERX was just open-minded, like, these are the broad topics we're interested in, propose what you think are relevant technologies in this space. And through AFWERX, we also got a decent amount of funding. So about $1 million from AFWERX, about $1 million from DOE, a little bit phase one from NSF. And then California also has significant grant funding sources. So early on, we did CalSeed back in 2017, got a phase one grant from them, I think for a small amount, maybe 150,000, 125, something like that. But then I think the biggest areas we've had success in was with the California Energy Commission. So California Energy Commission started coming in a little bit later. Back in 2019 was when we got awarded our first grant. So the timing came in at a critical juncture when we were having trouble fundraising from more traditional sources. And that CEC funding really was instrumental in allowing the company to survive through that period and ultimately to turn into our successful acquisition story. And so since then, CEC has been very supportive with their technology development and manufacturing scale-up grants and have had very good experiences there as well.
Were there any failed proposals, grant proposals? And if so, any lessons learned from that process?
We had many failed grant proposals, especially in the early days. I think we submitted to NSF 3 or 4 times before we got something. Definitely. We also submitted to NIH at one point. That was a bit of a leap, and to a number of different DoD ones. I would say maybe spent a little more time than we should have, honestly, on grant proposals at that early juncture. But, it is what it is. I would say lessons learned are that to some extent, there isn't that much of a lesson learned, because the lesson learned is that the process is somewhat random and you just have to keep submitting. You don't need to try too hard each time. Just keep submitting and the numbers game will play in your favor over time. So that was, some of our worst proposals that we spent very little time in ended up giving us the most money. So quality and likelihood correlation is pretty low. So just keep trying is one lesson. I would say the other lesson is to figure out the dynamics of each program, because different programs really operate very, very differently. And some programs you just hit a brick wall and you'll never be able to get through because of some factor or another, and other programs will be highly receptive to what you're doing. So don't just get stuck in one track and keep trying to figure it out, but keep your eyes open to a whole bunch of different programs and see what ends up working depending on the type of company you're building, the type of technology you're doing, and so forth. Different programs will then appeal more or less.
Any factors or dynamics that stand out in your journey?
One aspect I would say is a lot of grants are remarkably academic, which is something that really frustrated me, given that these are grants ostensibly designed for companies to commercialize technology. But all the reviewers, most of them typically ended up being professors and academics. And they would just go back to how they would review an academic grant. It's what is the fundamental technology risk and sort of how novel is this relative to the state of the art? And it's that's not the relevant question you should be asking. You should be asking, is this a viable business that can get to scale and get to market? A lot of grants ended up really focusing too much on, let's say, the core technical innovation elements rather than does it make sense as a company. We struggled with the NSF because of that. They were more focused on earlier stage innovations, whereas DOE was more interested in, how's your prototype going to work? Is this going to make an impact in the EV industry and so forth? So I would say that's definitely one element, is figuring out, on the other hand, if you do have a technology that's hugely novel, then those programs could work really well. But at least in our case, because of our company story, we actually went through a technology pivot as we exited Stanford. Our technology ended up being done from scratch. And so we had to focus on the ones that were more commercially oriented, not so technologically oriented.
That's a major complaint I have with SBIRs as well. And the people reviewing them, if they're not themselves business minded, they just hit that brick wall. I really hope that improves. Well, let's go back to something you mentioned, that you had a tough time fundraising with traditional VCs and other people. What was that journey like? What was the feedback you were getting from those people, the signals and the noise? Any good lessons learned there?
Certainly plenty of lessons. Where to start? It's a very big topic. I would say, at least for myself personally as an entrepreneur, fundraising was never one of my favorite activities. I was much more focused and enjoyed execution rather than raising from investors. And, there are some good investors out there, but there are many more investors who are bad and who don't know what they're talking about, ask the wrong questions, make decisions about things that are not really truly related to the substance of what your company is doing. And I think that's one actually big lesson learned is you have to figure out what is the game that each VC is playing and what does success mean for them? Because truly every VC looks at the world in different ways. A lot of those elements end up becoming much more significant than how good is your company or like how good is your pitch deck. And it's things like, okay, is this an industry that this VC would even go for, like at the top level? If they don't believe in this theme, you're never going to get there, no matter how great your company is. Is your sort of business model and exit strategy aligned with what this type of a VC is going to go for? If not, like it doesn't matter how great your pitch is or how good your company is. And there's like a host of other things like that that are just like not about who you are. It's just they're never going to invest in you. And you need to be able to see those signs so you can process and filter the investors efficiently. And then there's other elements like how do you generate momentum with a VC and how do you sort of create a fear of missing out to, drive them to act and to go and invest, because very few investors actually are willing to take the leap and become the lead investor. And finding the lead is always the sort of most difficult aspect of putting together a funding round, is somebody who is bold and actually will take action rather than just following other investors. And so also a lot of, let's say, negotiation and sort of emotional considerations associated with investing. And again, I think one aspect I was frustrated by was how little the investor decision-making process seemed to have to do with the substance of the company and what they had actually achieved and so forth. Somewhat unfortunate. What I saw was that strategic investors, at least for us in the hard tech world, could be better because they are more focused on what it is that you actually achieve and whether you will make your product rather than on, let's say, the broader themes of what they're trying to invest in. And so I think that's partially inevitable. I don't think it's that investors are necessarily all just closed-minded or anything like this. Like, I don't want to stereotype the industry. I think it's that the truth of what makes a VC business model tick is a few very specific things that don't actually have a ton to do at the end of the day with how your company is. And it's more about macro trends and, whether you pick the right timing and things like this, and you're in the right place at the right time, that defines your fundraising success to some extent. So you can always, obviously, around the margins, find opportunities, but that's kind of what I saw is really figuring out, do you fit with those sort of more macro type considerations?
Maybe we should write something, a separate topic, just create a resource. I think I have all these fantastic founders like yourself gone through the fundraising process, and there are various lessons and like things not to do. Talked about strategic investors, and Boeing Horizon X stands out as doing some research in a company. Can you talk about that investor and how you ended up with the relation with there?
Even with Boeing, who I was quite happy with as a strategic investor, although they're not investing anymore. They spun out Horizon X to a private equity firm. But even with Boeing, right, it was very much in some sense driven by macro trends. If I try to go today to raise from Boeing, I don't think it would matter what kind of company I was running. They're not in a state to be investing. But back in, when was this? 2017, Boeing was like at the top of the world. People were commenting on how like Boeing was the company that was at the highest growth rate in the S&P 500, even higher than many of the tech companies. They were on the top of the world, huge cash flows, very active in innovation and in spending. And that probably more than anything unlocked why they ended up investing in this risky early stage battery startup. But they did. And how we got in touch was actually through another incubator program. So this was one that we did not formally participate in, but we actually did a couple of pitch days, events that they held for strategics. It was called Starburst, and it's an aerospace focused accelerator for startups. We did one of their investor pitching events, and it happened that Boeing was in that event and got quite interested in us and followed up with further technical diligence and discussions. And it led to their seed investment in early 2018, which ended up being hugely impactful, very valuable as an investor, quite a bit of value add as a customer and in terms of validating the company, and played no small part in our eventual success. And they were a quite professional investor, good to work with, professional, strong personnel. So overall, and also I think from a term sheet perspective, fairly forward thinking in terms of not being as, let's say, aggressive as how some strategic investors try to be in terms of preferential rights and terms and so forth. So ended up being a very good fit for us at the end of the day.
You're not in focusing in that space, but then you just happened to pitch and they saw you, they liked you. I'm glad things worked out. Maybe that's a good segue to talk about the market side of your business. I believe demand for batteries and better battery technologies is universal. Can you talk us through the process of your market evaluation while deciding on a specific market, which in your case seems to be aviation, if I'm not wrong? Why didn't you go after the automobile industry like everybody else?
A lot of this is informed by Steve Blank, the Lean Launchpad platform, which also ended up inspiring the NSF I-Core program. And it's really focused around customer discovery and MVPs at the end of the day. Essentially, the concept is when you are building a new technology startup, you need to identify who your early adopter customer is. Because the reality is that the early adopter customer is typically not the customer that has all the volumes. The customer that drives all the volumes tends to be a late adopter that is buying commodity technology and is very cost sensitive and does not lean into technology innovation. That's typically what the middle of the market wants. Whereas for you as a startup, you need to figure out that very, very small niche where you are solving their burning need. And that's kind of the lesson of Lean Launchpad and all these other sort of startup and I-Core as well, is to do a ton of customer discovery and figure out what is that niche business that you can build early on before you scale to large volumes. This actually was also the critical takeaway from Peter Thiel in 0 to 1. The concept of 0 to 1 is that you should look to dominate and monopolize a small market, not be a small player in a huge market as a startup. And really find that niche small market that really plays to your strengths, because that's the one that generates outsized profits and allows you to scale before you get to large volumes. And especially in clean tech, the large volume is as close to a true commodity market as you can get. It's energy. There literally is a commodity, ultimate definition of a commodity. And a battery, for example, that stores electricity on the grid is pretty close to being a pure commodity because you're just storing energy. There's not much value in that activity at the end of the day. In EVs, it's a little bit different, but still almost a pure commodity because it turns out that lithium-ion batteries are actually pretty decent for EVs. Yes, they can be better, but not at the expense of a more expensive battery. Cost is the most important factor for automotive. And so what I realized is looking at technology adoption life cycles is automotive pretty clearly, if you look at it from its fundamentals, has all the hallmarks of being a late adopter market. I still wonder why so few companies seem to both recognize that fact and act on that fact, but it is a pretty clear truth that the automotive industry does not drive innovation at the end of the day. And so I ended up trying to look for what were the industries that would drive innovation and lean forward into technology, and landed upon aerospace as one where they do have a demonstrated history of adopting high performance materials and technologies, particularly if it saves weight. Because if anything saves weight in aerospace, it provides this outsized value proposition that saves the customer huge amounts of money and justifies spending high price points and leaning into early technology to adopt it. And I think carbon fiber is a perfect example in the aerospace world, where they really led the world in terms of adopting carbon fiber well before any other industry. I see lightweight battery technology as being similar, where the automotive industry is driving a lot of innovation out of necessity because of the critical issue of battery weight for electric aircraft. That was the high level thinking that got me into aerospace. And then it happened again, timing is critical. We started getting interested in aerospace right around the time where aerospace itself was becoming much more innovative. I think a lot of this came out of the success of SpaceX and really turning around the aerospace industry, and with investors realizing that there could be a lot of money to be made and a lot of innovation that can happen quickly in aerospace. That spurred on the launch of all of these electric aviation startups. And with that, Boeing as well and Airbus getting involved in electric aviation. And that spurred a huge amount of interest in battery innovation because of that. We managed to latch onto this trend early on back in 2017, sort of formalized it with our investment from Boeing in 2018, and continued to be laser focused on aviation because of the fundamental dynamics of what drives that industry.
You mentioned NSFI Core, which means you must have talked to a bunch of customers. What was that evolution like? Are there bad questions you were asking previously? And how did that evolve into the right kind of questions? And was there an aha moment where you said, aviation it is for us?
It's a difficult process. I started to realize at some point that it was not a one and done kind of process, but a continuously ongoing journey of customer discovery. And I think the balance I was trying to find was how to find the right balance of how to use a customer discovery process, like something like I-Core. And what I mean by that is if you look at the process too literally, you can end up in a place where all you've done is find yourself in this extremely narrow niche where at some point you're not doing something that anybody is excited by other than this truly tiny niche. And to a point where it's not just the issue of the niche, but the fact that pursuing this niche ultimately also has significant impact on your technology development strategy. And if you develop your product for this niche, you have to recognize, is it coming at the expense of where I ultimately want to go, which is actually a bigger market? And balancing sort of pursuing a niche where you can really dominate a market and add value, but not have that niche be so different that it becomes a distraction from your ultimate business vision. So I think we suffered a little bit from this early on and being almost too aggressive in pursuing that early adopter. And it led us to places like medical devices, just because there were some specific elements of our technology that happened to potentially be relevant for medical devices. Or it ended up in places like military, where ultimately procurement cycles were way too long to make a business out of it. And it ended up being like a very custom product. And also oil and gas. Our first ever investor actually was an oil and gas investor to make high temperature batteries. It's a very sort of interesting story of how we ended up there. And to this day, I still don't know if it was the right decision, because yes, it did open up money way earlier in our company lifecycle, but also arguably was a distraction from a product development perspective compared to where we eventually wanted to go. And so aviation, after a few stumbles in oil and gas and medical devices and so forth in military, aviation ended up being that right balance where the needs of the aviation industry were not so far removed from mainstream markets that it was a distraction. It was still big enough that on its own right, it was interesting as a business. And it was something that was also rapidly growing and very exciting at the time. So you do customer discovery, but balanced with other elements of your business strategy. Like nothing on its own should be taken too literally in incorporating these principles.
And a very, very important lesson. I think too many people take it literally and they do go down different paths. I think one reason is like money. They see some initial money, they go down those paths, and like, I don't know if there's a way to prevent people from doing that. But I think some of the lessons learned from you will be very helpful. Well, I think there are a lot of lessons that you've mentioned so far, but let's go to your acquisition by Northvolt. You raised about $3.5 million, pretty lean operations compared to all the fundraising craziness that you see in the Valley. Can you walk us through your decision-making process of like how you decide not to go raise more VC money and thought being acquired was a better option? I think this was a theme from the beginning. You were very, very intentional about this.
Some of these lessons originated from Stanford Ignite, where we first learned about VC business models and also learned about things like control provisions and governance rights and blocking rights and preferred shares versus common shares and so forth, and all the different things that investors can do to control your destiny in some sense. And so what I recognized was that, one, you don't want a misaligned investor because, okay, even if theoretically you have the ability to overpower them and do what you want, it leads to a place where nobody is happy and it adds a lot of risk to your future business. So you do need to be fundamentally aligned with your investor on what success means as a company. And two, be very, very careful about negotiating control provisions. So in the sort of dynamic of optimizing for value versus control, I always optimized on the control side and made sure I had proper control of the company and the board between people I trusted, advisors and things like this that saw my vision for the company, so that if we needed to do an acquisition like with Northvolt, we could do it. And that's ultimately, we did use that ability to still have control of the company to ultimately pursue that acquisition. So taking a step back, if you look at investors, what we decided early on was to not pursue traditional VCs. We're quite intentional about this. Cyclotron Road gave us quite a bit of runway to avoid needing to raise a lot of VC money, as well as this oil and gas investor, which, good or bad, perhaps the technology bit was a bit of a distraction, but it did allow us to significantly delay when we would need to raise additional funding in the early days until we de-risked the company. And then we found Boeing, which ended up being another great find. So again, that allowed us to buy even more time. And then at that point, we were into 2018, 2019, already been 4 years in the company without having raised any traditional VC funding, only strategic funding and grant funding, which up until that time, I think totaled maybe 5 or 6 million by then, if you count the grants as well. But we were reaching a point where it was becoming very, very difficult to fundraise. I think part of this was related to the fact that I was fairly outspoken about our intentions to go through a strategic acquisition and about our interest in aerospace. And both of those signals ended up being significant factors in most VCs kind of automatically discounting us or deciding not to invest in us because, one, we weren't pursuing automotive, even though that was our long-term goal, that was not our, immediate goal. So they discounted the size of the market, the TAM, and they also discounted the fact that we wanted to pursue an early exit. And should I have been more, I don't know, should I have revealed all my cards? It would have made raising money easier if I just told them, okay, we're going to pursue automotive, we're going to go big and go IPO. But I think it also would have been somewhat dishonest and ultimately would have led to, again, the investor misalignment I was always concerned about. So I ended up being fairly straightforward with investors. That led to many investors not being interested in Cuberg, I think mostly for the better. But we did reach a point in, I was mentioning early mid 2019, where we were getting close to running out of money. A couple of investor discussions fell through. We were continuing to pursue some strategic investors from the battery industry, but that ended up not working out. That was some of the early, external validation that failed that I mentioned, back when we really didn't have a control over our quality control yet. That didn't go so well. And then we were at one point only a few months away from running out of money. Very, very stressful time in the company's history. And it was right around that time where actually we got a couple major grants with the California Energy Commission and with DOE that bought us a few more critical months of runway that ended up then unlocking actually some bridge funding from an angel investor, which I'm very grateful for. And then that in turn ended up giving us enough leverage to then sign a term sheet with a Series A investor. Quite sort of an unexpected turn of events in the span of about half a year in 2019. And then we then used the leverage from having signed a term sheet with a VC to then drive the acquisition discussion with Northvolt. And so Northvolt had reached out to us to visit in late 2019 based on actually a meeting I had with their CEO back earlier in 2018 at a conference, again, like a unplanned coincidence, but they were doing technology scouting in 2019, talked to us, learned that we were about to close a funding round, but at the time we're still very attractively sort of lightly capitalized, and decided to basically make a move and try to acquire us. Ended up signing a term sheet with them in early 2020. Then we didn't take the investor funding. We ended up going with the acquisition journey. And then ultimately, after a bunch more sort of negotiations and so forth, closed the deal with them in early 2021. So it's been quite a crazy journey, coming within months of running out of money and being super, super lean. I would say this is about as lean as we could really have executed on this plan. Partially not intentionally because we couldn't raise money either, but as lean as possible. But it ultimately worked out super well in terms of the acquisition and also for our strategic investors, and really has accelerated our progress, both in terms of the resources we could tap into with Northvolt, as well as the ability to leverage capabilities and engineering expertise to ramp up manufacturing and scale.
This is a fascinating story. I like the way you are sincere and truthful about your plans of being acquired and didn't change that, instead of trying to tell a different story, lie. Many probably would. What was that acquisition story like? What was your team that was helping you on this M&A? You never done this earlier. With the people helping you form this bond there?
There were certainly also many lessons learned along this journey. Definitely, we had some critical advisors. So actually, I mentioned Brian Bartholomew's from Stanford. His brother, Michael Bartholomew's, actually is a longtime technology entrepreneur who also became an advisor to the company starting in 2016 and was very, very close to Cuberg. And so he was a critical resource for really advising on the M&A journey. He was also a part of our company board. And so our board also provided helpful input and advice. Of course, we had our legal team from Fenwick & West who did a lot of the legwork and negotiation. And eventually we also hired on an M&A advisor, sort of boutique investment bank that helped us with the transaction. I think in retrospect, I would have brought that person on sooner if I had known about that person. That's probably one lesson, because it is a very, very difficult thing to do in M&A. But definitely just a learning process all the way through, right? And trying to find advisors, trying to find different resources and just working through it. And just a ton of negotiation, building personal relationships with the acquiring company and the key individuals there and making it happen.
I'm taking a lot of your time because I get so few founders like yourself who go through all the way from founding a company to getting acquired. And there's so many lessons that people could actually be looking at. Thank you for your patience. Are there topics that we haven't covered today?
One maybe just somewhat unrelated element is on the product development process. One piece of advice I would give to founders is to some extent, don't drink your own Kool-Aid. And having other people get exposed to your product is infinitely more valuable than you testing it in-house. Because, you can try to be as honest as you can with yourself, but intrinsically there's some level of bias that comes from your own team evaluating your own technology. Making prototypes, testing them out, even at a very early stage, shipping them to other people, whether it's a customer or a lab to test, is infinitely valuable. And to do that as early as you can, build those commercial prototypes or pre-commercial prototypes and run the validation so that you really can be honest with yourself and your team can be honest with themselves about what it actually takes to get something to market. The surest way to really gather intel is to do that. I think it's also, I don't know wasn't there some famous Muhammad Ali quote, or maybe it was Patton, I don't know. You can have the best plan going into a battle until you get punched in the face or something. And then, all bets are off. So it's better to take that punch early, I think, is my advice.
Absolutely. I mean, that's a great lesson. Don't take your own Kool-Aid and expose your product to potential customers. Get that feedback early on. That was a very valuable lesson there. Any plugins on behalf of your company for the listeners? Any hiring that you're looking at?
We're certainly continuing to hire a lot of key positions, both for battery cell development as well as battery module and systems development, and then also quite a few manufacturing quality process roles. So definitely look out on our company page if you're interested.
I will have a link for that careers page on this podcast page. And now on to my traditional closing questions. If there are one or two mistakes that you would avoid, what are the lessons that others could take away from your journey?
I would say, honestly, with hindsight, it's really hard to say what would have happened if I had not accepted the money from the oil and gas investor. But I think I probably could have found a way in retrospect to strike a better deal with an investor that was more aligned with where we ultimately wanted to take product development. And even, taking that deal with the oil and gas investor early on had some negative impacts also on company culture, because ultimately we were in this to make an impact on the clean energy world. And it really wasn't easy for people to see why we're developing this niche high temperature battery technology for the oil and gas industry. So looking back, I would say I would be curious to take that other road and see what happens with a more focused development approach. And then I would say I would want to be much more intentional about establishing my company culture early on. And it goes hand in hand, I think, with what I just said on the investor side, but really just being very explicit. You put it on your website, your key values, and really think about those values, what they should be that's unique to your company, and to live them and to communicate them to every single hire that you make and to interview people for those cultural values. Make them very actionable and concrete, because that ultimately allows you to build a team that works together so much more efficiently and is committed to the company for something beyond just collecting their next paycheck. That's been critical to really have people see the long-term vision.
Great lessons there. Are there one or two significant people in your journey without whom this success would not have been possible for your startup?
So many people. I would say especially Ilan Gur and Matt Price at Cyclotron Road, now Activate. Brian and Michael Bartholomew's from Stanford and Michael, our longtime advisor, have been critical. And also, I would say, a little more recently, Reza Nikfar, who is now our COO, he was actually a manufacturing consultant that I was introduced to from Michael, and ultimately ended up joining our company as COO a couple years ago, and has been instrumental in our success the past few years. It goes to show you sort of the serendipity of connections. You don't really know where these lead, but Brian led us to Michael, and he led us to Reza, and it just keeps going. It just keeps on giving, right? Once you build these networks and make these friends and allies, they really just keep helping you all along the way.
Indeed. Richard, thank you so much for all the lessons you've shared with us. I've learned a lot. I'm sure my audience is going to appreciate all the lessons you taught. Thank you so much and good luck with everything.
Thank you. It's great to be here.
Thank you for listening to this episode of the Lab to Startup podcast. You can find links to the resources and programs mentioned in these episodes, connect with Naresh, or subscribe to this show at labtostartup.com.